Experimental data analysis questions come up a lot on all A-level biology papers and exam boards. And in AQA paper 3, you will find a 15-mark critical data analysis question. Now, the purpose of these questions is to test students' skills of inference, application, analysis, evaluation, and study design. We will talk through here the most common errors students make and help you understand what you are being asked and how to identify clues to the mark scheme. Now, I am not talking here about simply understanding describe versus explain. The inference is far deeper. And it's also important to note that mark schemes for study design questions appear to be getting more specific with wording, directing students not to reference certain aspects of the study design. And this is to avoid students using a few blanket statements they have memorised. Now, here are some common mistakes, and you might be thinking, I know this already. Well, you might, but you are still losing marks on these. So please watch carefully to see how minute details in the wording of the questions will lead you to the mark scheme. Please understand that the examiners who have written these questions have had serious discussions about the wording of the question and the exact wording on the mark scheme. They are also likely to have done trials internally to see the answers that the wording of the question might prompt someone to give, and then tweak their wording further. So let's start with deciphering some of the common instructions or command words in the questions that come up on this question type. Let's start with clues about what data or information to include in your answer. Now, if they talk about using the data, data refers to values seen in graphs or tables, so make sure you reference them in your answer. Information is wider and can include names of substances, processes, details on study design, and again, you must reference them in your answer. Name the experimental group, the species, the molecule name, the drug. Use the axis labels and table headings in your answers. So here are some example question stems where you might be instructed to use all of the information. And this means everything. All charts, tables, introductory information, or even the individual question stems from previous questions of the same question number. If you only use some of it, you will be missing a number of marking points or fail to make some of the connections necessary to explain observations. Some questions will only direct you to very specific parts of the question, maybe one table or graph. Some questions will ask you to use all of it, but not comment on certain pieces of information. So I've highlighted in green where these clues are, and I strongly recommend you annotate the questions as you read to focus your mind on these clues. Now let's look at some different ways they will ask you to describe a method or way of working. And it's really important to consider the subtle variations in these questions to ensure you get the marks. Some of them are more straightforward, such as describe or outline a method. And this needs to be future tense, and a good method would be a logical sequence that includes variables, equipment, references to repeats for reliability, and don't forget, as some students do, what will you look for or how will you process your data? How would you find is a bit more targeted, and you may need to focus on a more specific area of the method rather than outline a whole method. Suggest how to determine is asking you to connect a method or subsection of a method to analysis that will be done. So be clear about what pattern the student will need to look for in the data. Now, the next one is a common version that trips students up. Describe how they would have found or calculated the information. This requires you to look at the data they've got and describe a very specific version that would lead to results with the units given. For example, if mitotic index is given as a percentage, the calculation would need to reflect this. However, if it was an index between 0 and 1, the calculation would be different. Now, explain how the student calculated needs to have explanation, not just description. For example, don't just state measure the scale bar and convert into micrometers. You need to measure the scale bar using a ruler, then convert into micrometers by multiplying by 1000. Another question you could be asked is to identify the incorrect mathematical step. And here you need to work it through yourself Then try to work back to see which of your steps the student went wrong on. Often the wrong data has been used or a step has been missed out. You might also be asked to critique or suggest improvements to a method, and there are three parts these answers have in the mark schemes. What should they change? For example, control the temperature. How will they change it? For example, using a water bath and pre-incubate solutions before starting the reaction. And then why? Because temperature will affect the rate of enzyme substrate complexes formed in a reaction, and pH is our independent variable. If you're asked to suggest a further investigation, this cannot be completing a statistical test on the data. It needs to be a new but linked study, not a repeat. So be clear what is staying the same, what you are going to change, and what outcome you will measure. You may also be expected to explain the importance of specific steps, so make sure with all your CPACs you know why significant parts of the method are important. Now, the next few questions are commonly asked, but students don't answer appropriately or use the same answers for all. Different factors contribute to validity, accuracy, and reliability. Now, when asked about validity, you should straight away be considering if control variables have been used correctly, or if the sample is representative for the aim of the study. Accuracy is how close to the true value results are, and this comes from selecting the correct equipment and measurement strategies and using them without systematic error. Reliability improves by repeating the experiment, obtaining larger data sets, and if any anomalies are seen, repeat these measurements. At A level, we don't just ignore anomalies, we repeat to replace them. Now, significance of differences can be assessed by observing the absence of overlap of standard deviations or ranges. For the significance to be considered statistically significant, a statistical test would need to be done, but it is vital that you look at the type of data and name an appropriate test for the study. Now, graph drawing is a fundamental skill, but don't take shortcuts if describing how to do it. Uncertainty is something you could be asked about, and it's a math skill that students often struggle with. So make sure you understand in all of your CPACs how you reduced uncertainty, either by repeating measurements, using high resolution measuring equipment, or measuring in larger increments. Now, the next four relate to control experiments and controlled variables. So make sure you know the difference between these and also the difference between a positive and a negative control, and be able to justify their purpose. Let's move on to suggest and explain, which do seem to cause students problems, largely from not extending their answers enough or linking clearly. You will often see on the mark scheme 2 points connected by so or because, underlined and in bold, both points being required for 1 mark. Ultimately, you need to give an idea, then link it to a justification or explanation, and sometimes it will involve making observations from data and explaining your conclusion based on the observation. Sometimes the commands suggest and explain will be explicitly written, but look out for suggest why and suggest how. Moving on to our command word explain, you need to look very carefully at what you are being asked to explain, as you would have to for suggest and explain. Are you explaining all of the trends observed, in which case you will need to give scientific reasoning for all trends on a graph, as well as explaining any differences in trends between lines, or is it just explaining the differences between two trends? If the command includes describe or a direct reference to using information or data, then you must quote data, axis labels, substance and process names in your answer. Sometimes the explanation may take the form of a prediction. Sometimes there may be specific guidance as to what background knowledge you are expected to apply. And other times the explanation may take the form of a justification rather than explaining an observation. So this leads on to our command word conclude. Here are a few different ways that you might be asked to form your own conclusion, and you will see the word conclude does not even have to feature in the question stem. The most important part of conclusions are that we only make statements about what we do know and we don't overstate or extrapolate findings. Forming a conclusion will involve some evaluation of the data to work out what is scientifically safe to comment on, but we don't need to show all of the process of evaluation in our answer unless asked. A very common conclusion that you will be expected to make involves the interpretation of statistical tests, which students often find tricky. So I will show you an easy conclusion scaffold to hit all of the marking points. You can see in the bottom questions, we might be asked to form a conclusion from a p-value, or we might be given a calculated value and go through the process of selecting and or comparing it to a critical value at p 0.05. Now let's just remind ourselves what these different values mean before we go through the mark scheme scaffold. We might have a calculated value from the statistical test. You won't be asked to process all of the data yourself to produce this, but you could be asked to do some final working on some part processed data. We then have to compare it to the critical value for P 0.05 at the appropriate degrees of freedom. I want you to imagine the critical value like a high jump bar that we need to exceed for a successful significant finding. The p-value is the probability the correlation or difference observed is due to chance. Chance is not a good thing. We want real findings, so we want a low p-value. Do not make the mistake of comparing the value 0.05 to the critical value. The critical value is selected by the p-value of 0.05. Degrees of freedom reflects the size of the data sets and therefore the statistical power of the test. The larger the data set and the larger the degrees of freedom, the critical value will become less strict and easier to exceed for a given p-value. Finally, make sure you select your wording very carefully for your null hypothesis. The wording must reflect the statistical test chosen. So choose the words difference, correlation, mean appropriately to ensure you get the marks. Now, to help you, here is a summary of the 3 tests you need to know, when we use them, and the wording for the null hypothesis. The t-test is for comparing differences between means. So these 2 words, difference and mean, must be shown in your null hypothesis and in any conclusion. Don't just look for mean in the data, look at the aim of the study before deciding on the t-test. The rules for determining the degrees of freedom will depend on if the data is paired, for example, a before and after on the same subject, or if the data is unpaired, where the 2 categories are independent, for example, the mean diameter of the xylem versus the mean diameter of the phloem. Chi-squared is used to determine if frequencies of categoric variables observed are different from those we would expect. So the words difference and frequency must feature in null hypotheses and conclusions. Then correlation coefficients, such as Spearman's rank, is used to determine if any correlation is statistically significant. So we need 2 continuous variables for a correlation, and the value calculated will be close to -1 for a strong negative correlation and close to +1 for a strong positive correlation. The closer to 0 the value is, the less significant any correlation. So if we need to form a conclusion from a p-value, we look for whether the p-value is higher or lower than 0.05, and we use a 3-part hypothesis using a statement of significance, referencing the probability the difference or correlation is due to chance, and a statement on accepting or rejecting the null hypothesis. Pause the video and read through the 2 conclusions for the 2 scenarios here: less than 0.05 and above 0.05. If we are given information on the calculated value and the critical value, we have to see if the calculated value exceeds the critical value. Now remember, for a correlation coefficient, you need to ignore the negative value when comparing to the critical value. But do remember that your correlation was negative. Here is the scaffold for the 2 conclusions you might have to write. Please remember, you cannot say the results are or are not significant. You must choose appropriately from difference or correlation. Finally, we come on to the slightly different ways you might be asked to evaluate. An evaluation must reflect two sides of a debate, and even though there are often many marking points for a 3 or 4 mark question, you will not be allowed full marks if you only present one side of the argument. Now, please remember, benefits versus risks are different to advantages and disadvantages. Are you being asked to evaluate one drug and whether it is effective or not? Or are you being asked to compare effectiveness of two drugs? Are they asking you to do a complete evaluation of the results, in which case you will need to go through the complete checklist I'm about to show you? Or are you being asked to evaluate a conclusion already formed by a scientist, in which case you are looking for trends that support their conclusion or any overstatement or extrapolation to non-representative populations? Now, some question stems do not contain the word evaluate, but there is clearly two sides of an argument to present. And this might take the form of comment on the validity of the results or conclusion. Now, the key to nailing evaluate study questions is to pay careful attention to the study design and work through a checklist in your mind to build your for and against argument. There's a lot to work through, and not all information will be available for you to comment on, but the checklist largely falls into 3 parts. What evidence is there to support a conclusion? Clear trends, for example. What evidence is there against the data? All that we don't know, anomalies, gaps in data, no control group, maybe no long-term safety data or information on side effects. And thirdly, what else could be influencing the results? Look for control variables that haven't been controlled or a bias in samples which make the results not representative of the wider population. My students love this scaffold, and it really does make these questions a piece of cake. So just be careful with your wording and avoid unqualified statements such as small sample size or no stats test. The mark schemes have moved away from crediting these basic references, but you may still gain marks from them providing you qualify them. For example, there is a small sample size, so the results may not be representative of the wider population. There is no statistical test, so we do not know if differences are statistically significant. So I hope this has been helpful in giving you some greater insight into what the examiners mean by their specific wording in experimental data analysis questions. If it has, please like and share. If you have any questions, do leave a comment which I'll respond to. A link to a summary document of all the question stems and meanings used in the video can be found in the video description. Watch out for a guided run-through of a 15-mark critical data analysis question where we model how to approach these question styles and practice applying our skills of inference and the appropriate wording of our responses. You may be asked to complete some calculations in these question types, so ensure your maths is up to scratch with my video on maths equations you must be able to recall.